Okay, so as of now, we're being recorded. I'll let you know every time we start class to make sure that you guys are aware of that. Just because some people don't like being recorded, and that's perfectly acceptable. So, that's the seating chart. We're going to go jump back into 1.1, and I'm going to try to kind of speed up a little bit through some of this review stuff. And then we'll try to move on to 1.2, and we'll see how far we get. Please keep an eye on my time. If I start going past 10:30, stop me.
Did you post the notes for that section 1.2?
I've posted the YouTube video, so you can view the YouTube video if you want, but do you mean you want a PDF version of the notes? Oh, yes, okay.
Yeah.
No, I haven't, and I can't right now because I can't connect to the Wi-Fi here. Thank you for that. Okay, from here on out, I'll be posting those. Actually, probably I'll just post all of them in advance. Okay, let me make a note of that. For today, please just follow along on your notebook as best you can, and yeah. Okay, so we left off talking about sets, and I believe we started talking about how they're essentially a collection of numbers, and we talked about what an interval is. An interval is a set of numbers, and it contains every number between those two endpoints, and depending on whether we have a square bracket or a circular bracket, I guess, then it's going to either be closed or respectively open, which means we either include or respectively exclude the endpoints from our set. Okay, so that was open and closed. So a domain, this is still review, is a collection of numbers, i.e. a set, which describes all possible inputs for our function. Okay, so remember we talked about our function as being kind of like this TSA machine where we've got some input coming in and then something happens in our box and then we get an output spit out. So in terms of this analogy, the domain is the set of items which we can put on this part of the conveyor belt and send it into our machine. Okay? That's what the domain is. Okay? Correspondingly, the range is also going to be a set of numbers which describes set of numbers which describes all possible outputs of our function. Okay. A lot of people struggle with domain and range, especially when it's their first time taking calculus and they haven't necessarily solidified those concepts yet. So if you're confused about that, I'd recommend that you come to my office hour today, which will be online from 12 until 1. So after class today, I'm going to go home and I'm going to post an email to everybody. It's going to include the link for you to connect to the virtual classroom and come to my office hours if you have questions about some of this review stuff.
You got homework today?
I have not posted any homework assignments yet. I probably will post a homework assignment on Wednesday or Friday. I'll make sure to give you proper notice. And by the way, the exit slip has been extended. Did everybody get my email about the exit slip? Okay. If not, you can read the email.
Do we do that after we complete this lecture, or?
Yes, so you'll have to complete an exit slip for a given lecture within 1 week of the lecture being posted on my YouTube channel. So if you come to class, you'll have seen it by that time. Otherwise, you can watch it on your own and do the exit slip. Any other questions about the exit slip stuff? Yes.
When I saw the due date was past because it was August 24th, 2010, I went ahead and did it because it said due, like past due. Am I allowed to submit another one?
Yes, you certainly can. And I'll take a look, and for the first exit slip, I'll reach out to anybody whose thing is looking weird, and I'll be like, hey, let's get this figured out. Don't worry about it. I'm not going to like start penalizing people before we have our setup figured out. Okay, so moving on, a graph is also going to be a set. So a set, in this case, the elements of our set are not going to be just numbers. Can anybody go for gold and tell me what the elements of our set are going to be, if not numbers?
What alphabets?
Sorry?
Alphabets. Like A and B.
Not letters.
0.1.
The points on a graph are in two-dimensional space, right?
Mm-hmm.
How do we describe a point in two-dimensional space? With coordinates, that's right. An ordered pair, right? A comma B. Okay, this is how we describe points in two-dimensional space with an ordered pair. And a graph is going to be a set of all ordered pairs x comma f of x, where x is in the domain. Okay, so we look at all the points which are in the domain. We find the function value at all of those points. And for each point in the domain, we describe the point on the graph as the ordered pair x comma f of x. And the graph of a function is the collection of all such ordered pairs. Okay? So when we have a function like, for example, f of x equals x squared, looks something like this. What I'm referring to here is all of the points which are on this parabola, which satisfy this equation y equals x squared. Okay? Any questions about domain and range and graph? They're all sets. Okay, let's move on. All right, let's take a crack at this problem. So we want to take a look at the graph, and we want to figure out what is f of 4, and we want to figure out what should we put here in order to get 0 as on the other side of our equals sign. So take a second to think about it, and then if you're ready, go ahead and raise your hand if you want to answer part A. What should f of 4 be?
Is that 2?
Yes, it should be 2, right? So the way we figure this out, right, is first of all to recall that what goes on the inside of our parentheses is going to be our input. And we're going to always have our inputs are going to be written along the x-axis. Sometimes we'll call it the t-axis, but it'll be the horizontal axis specifically. And conventionally in mathematics, we use the output, which is going to be on this side. Conventionally, we plot the output as a vertical descriptor of our graph, okay? So we take an input from the x and we get out a y, and that's going to be the height of our function. So I imagine what was going through Sri's head when he started this problem was, I see 4 on the inside, so let's go to where we see 4 as an input. Well, let me circle it with red instead. We go to 4 as an input, And then we just go and find the point on the graph which corresponds to that input. Okay, so I just go up and down until I hit the graph. The height at which I hit the graph was 2, so that's going to be my output. Okay, who's got B for me? If my output is 0, what should my input be?
2.
Exactly right. Okay, so what I did that time was I just started with 0. I found where the height of my function was 0. It looks like that happens here. Okay, why did I do that? It happens right here. And then I just checked what is my input which corresponds to that output. Okay. So let's see here. We got A, B, C, D. We're going to try to figure out whether or not these are functions. Let's have these 2 rows. You guys do A. These 2 rows. You guys do B. These 2 rows. You guys do C. You guys do D. All right, for posterity's sake, or for the rest of the semester, as long as we're in person, I'll refer to these first 2 rows as group 1. You guys will be group 2. People who did C will be group 3. People who did D will be group 4. And sometimes we'll have problems like this where I'll split you guys up into groups, or if I just have A and B, then I'll say, okay, 1 and 2 take A, 3 and 4 take B, something like that. All right, for A, so group 1, would anybody like to volunteer and take a crack at whether or not this is a function? Yeah, go ahead. It is a function. Okay, and how do we know that it's a function? Want to go for gold? Yes.
I just figured that n would be the input,
Mm-hmm.
and that would result in the number of donuts equal to the output.
Exactly. So our input here, let's continue with our color coding. I've been doing red as the input, is going to be n, right? And the output is going to be the number of donuts that we can make, right? We'll call it D maybe. Okay. Oh, you know what? I should really turn these lights on. Is that better?
Mm-hmm.
Yeah, okay. Sorry about that. All right. So n is going to be our input and D is going to be our output. And one of the reasons that this is going to be a function is let's go ahead and scroll back up to what our definition of a function was. We said it's a rule that takes certain numbers of input and assigns to each input exactly one output. So far we've covered input and output, and the part that I would really like to highlight is this exactly one part, right? So let's think about why is that true for A. If I have n dollars, there's only one quantity of donuts with which I can make with that much dollars, right? If I have $10 on Tuesday, I can make 5 donuts. If I have $10 on Wednesday, it's not going to switch and have me be able to make 7 donuts on Wednesday, right? So for each input, we have exactly one output. Okay, that's the really important thing for a function. Okay. Thank you to you two. Can you remind me of your names?
Alice.
Alice and Ashley. Alice and Ashley. Thank you very much. Okay. Group number 2 had b, y equals z squared. What do we think? Is this going to be a function or not a function? I'm seeing a lot of head nodding, so that means yes. Yeah?
Yeah, yes.
Yes. Okay. You want to tell me why?
Well, it's just going to be a parabola, and if you did like the vertical line test.
Exactly. Yep. Yeah. If I take some number, say 6, and that's my z, and I square it, well, there's only one number which corresponds to the number 6 squared. 6 squared is 36. There's no other number which satisfies the equation that this number is that number squared. Okay? So this is going to be a function. In fact, we can even graph it. And as you said, it's going to be a parabola. Just imagine that goes through the origin. And as we can see, this is going to pass our vertical line test, right? Remember, the vertical line test is really just checking if I move my pencil along like this, is there a point where my pencil crosses the graph twice? That's what we check. And the answer is no, that's not going to happen. And if it were to happen, that would exactly mean that this x value here has 2 outputs and not just 1 output. So that's why it wouldn't be a function if it failed the vertical line test. Thankfully for us, it does. So it is a function. So the answers here were yes and yes so far. How about C? I think C is the most challenging of these so far. What does group 3 think about C? How about hands up for yes, it is a function? Hands up for no, it's not a function. I didn't see very many hands, so I guess we're not confident with our answer. Okay, maybe we'll do this one as a group. Can you tell me what's throwing you off about this? Yes?
In the denominator, if you put in certain numbers, the denominator can't be zero and that.
That's exactly the crux of it, isn't it? So Yasmin was talking about this denominator here. Let me highlight it. 1 minus x in the denominator. What happens if x is equal to 1? The denominator is going to be 1 minus 1. We'll have 1 over 0, right? And that's bad. However, it's not going to violate the fact that this is a function. The answer is yes, it is a function, because as long as x is not equal to 0, one input gives us one output. So what Yasmin is really describing here with this denominator possibly being equal to 0 has to do with the domain of our function. Remember, we said that on our conveyor belt, there's some things that we can put in the left side, and there's some things that will come out the right side, right? The domain and the range. So what is interesting about this function x over 1 minus x is that x equals to 1, the number 1 is not in the domain, i.e., that is to say I can't put the number 1 on my conveyor belt here and send it into the function. If I try to do that, the whole box is going to explode. Okay, so I cannot put 1 into this function. It's not in the domain, but otherwise, it's a perfectly acceptable function. We can even graph it. It looks something like, let's see, 1 minus x. It'll look something like this, I think. Yeah, should look like that. No. it'll look more like, let's see, if we're negative here, I think it'll look more like that. And then on this side, it'll go down like this. Something like that. All right, anyways, don't pay too much attention to the graph. What's really important is just to know that if we have polynomials like z squared, or rational functions, which are just polynomials divided by polynomials, they are going to be functions. You just have to be careful about the domain. Okay, so the answer is yes for this one. How about group number 4? We had D. Can somebody identify my inputs versus my outputs for this function?
The x is repeated inputs and y is repeated outputs.
Exactly. Inputs are going to be my x's, and the outputs are going to be my y's. And is it a function or not?
No, because the input 3 has 2.
Exactly right. 3 goes to the number 4, and 3 goes to the number 3. So we have one input going to 2 outputs. That violates the definition of a function, so it's not a function. Okay, questions about problem 6? Okay, I'm gonna move on. Problem number 7. Okay. Shannon decides to go for a run. For each of the graphs below, write a possible description of Shannon's run. If t is time in hours since the start of her run, and d is her distance from home in miles. So I'm going to do the first 2 for us, and then we'll all try number 3, okay? So the first one, we can see here on the horizontal axis we have time, and on the vertical axis we have distance from home. Okay, so the meaning of starting at the origin is that at time t equals 0, so at the beginning, we're at home. Okay? And then we go along here, up to this point. So how can we think about this? This is, as we move to the right, t is increasing, and distance from home is increasing, which means that as time moves forward, we're moving away from home. Okay? This point right here is going to be our maximum distance from home. Okay? And then we're on our way back down. So as t goes forward even more, our distance from home starts decreasing, and then we get to 0 back home. Okay? So this is like an out and back trip. Okay? I walked, and then I instantly spun on my heels and started walking back home. All right. So that's that one. Second one. Okay. This one looks a little bit different. Looks like we're just going up, and we don't go down at all. So the way that I'm going to interpret this is I start at the origin, so at the beginning I'm at home, and then as time goes on, I walk a little bit slower than I was walking in the first one. I can tell that I'm walking slower because more time has to pass for me to go further along, okay? So in this situation, it's kind of like I walked, and then I got to the store. Okay? Who can give me an example for number 3? Yes, Maxine.
It's looking like she ran for 3 hours and then she stopped somewhere, maybe.
Exactly.
And then started walking back home.
Yes, you're exactly right. Okay, so we start at home. We walk, and then this flat part, what's going on here? We see t is going to the right, so t is increasing, but d is not moving at all. We're not moving away from home, and we're not moving towards home, so we're standing. Okay, standing still here, and then we decide we're going to go home, and we walk back home. Okay, the one thing that I do want to point out is it's actually not 3 hours for which we're walking. It's going to be the time that we walk until we stop is going to be marked on the t-axis, and it's going to actually be 0.5, so half an hour, and then whatever d is measured in, I don't know, how far can you walk in half an hour? Maybe 3 kilometers? Could you walk 3 kilometers in half an hour? Maybe if you walk fast. Okay, yeah, so we could say like this is kilometers. So after half an hour, she's 3 kilometers from her house. Okay? All right, thank you, Maxine. All right, so we're going to talk about an increasing function and a decreasing function. I'm going to give you these definitions really quick. A function is increasing if when x2 is bigger than x1, whenever x2 is bigger than x1, we have that f of x2 is going to be bigger than f of x1. Okay, let me draw what I mean about that on a graph. What I mean is that if here's x1, if x2 is bigger than x1, where should I put x2 on the horizontal axis? To the right or to the left of x1? Should be to the right of x1, okay? So here's x2. And what does it mean for f of x2 to be larger than f of x1? It means that the height of my function at the x value x2 should be higher than the height of my function at the point x1. So what it really says is that if I have 2 points and one of them's to the right of the other one, then that point is going to be higher than the other one. In so many words. Okay, so if I move to the right, I go up. That's what it means for a function to be increasing. Decreasing is exactly the opposite. So whenever x2 is larger than x1, f of x2 is less than f of x1. So what does that look like on our graph? We've got x1, x2. And I'm saying that the point at x1 is actually going to be higher. So we're going down. Okay? So we're always moving left to right. Yes?
I think we meant to pull the arrow with the same other way. Because you put x2 greater than x1 again for the decreasing function.
Yes, and what I'm glad you pointed that out. What has changed here is this one. Okay, so we keep x2 larger than x1.
Oh, sorry. I missed
No, that's okay. Have I made a mistake? I think I did it right. Let's see, x2 is larger than x1. F of x2 should be less than f of x1.
okay, so it's still larger. And it's just that the function itself is going the other way then.
Exactly, yeah. So we're going to keep x1 and x2 just so that they're consistent in my mind. I just want to keep x2 on the right permanently, and we'll just decide whether it should be a higher point or a lower point.
Okay, thanks.
Yes, thank you for that question. Any other questions about increasing and decreasing definitions? We're going to do some practice in a second here. Okay, people feel okay about it? All right. Okie dokie. Y-intercept. Okay, so y-intercept. Okay. Let's have pencil. Is a point on the graph where, let's see, if we're on the vertical axis, then our x value is 0, where x is going to be our horizontal value. Okay, so what does it look like? I have some function like this. The point that I'm talking about is this one right here. Okay, and I can tell that the x value is 0 on this graph because I'm right smack dab in the middle in terms of left and right. Okay, an x-intercept is going to be a point on the graph where our y value is 0. And this is our vertical descriptor. So what does an x-intercept look like? We'll draw the same kind of function. Our x-intercept is going to be right here, where we cross the horizontal axis. Okay? In the book and in the homework, you'll hear them describe this as a, quote, vertical intercept. And on the x-intercept, they'll call it a horizontal intercept. Okay? So if we have a vertical asymptote, that means that our, not asymptote, sorry, intercept. If we have a vertical intercept, that means that our horizontal value is 0. And if we have a horizontal intercept, it means that our vertical value is 0. Kind of confusing how they name it that way, but what they're trying to describe is the fact that a vertical intercept is intersecting the vertical axis, and a horizontal intercept is intersecting the horizontal axis. Okay. All right. So let's go ahead and take a look at this big old word problem. And let's see, should we do it together? Why don't we do it together? Okay, so Kayla just finished college and finds that she has $66,000 of debt in student loans. Okay, that's a very real scenario for all of us. She is determined to pay it off and figures that she can pay $1,100 on her debt per month. So we set up a function d equals f of t, okay, where our input is t and our output is going to be d. And we want that to be the amount of debt that Kayla has left on her student loan t months after she began to pay it off. Okay, so let's quickly identify the input and the output. T is going to be my input, and t describes the number of months after we began paying our loan off. Okay, and then d is going to describe amount of debt that remains. Okay, so those are going to be our inputs and our outputs. Let me go back to black. So if we want to interpret f of 12 equals 52,800, and we want to include units in our answer, well, what this is saying is that our input is 12, so t is equal to 12, and t describes the number of months after we began to pay it off. So the significance of there being a 12 here means 1 year after start. And the significance of the output, which is the remaining debt, we still have $52,800 to pay to the bank. Okay? So what is the meaning of f of 25? Okay, so they didn't give us a figure here for the amount of debt that Kayla has left on her student loan t months after she began to pay it off. So what we're actually given here is just the fact that 25 months have passed. And this thing that we write here, when we write f of 25, remember that that's a stand-in for d. Okay, that's a stand-in for d. So when I write f of 25, what I'm referring to is the amount left to pay after 25 months. Okay, that's what f of 25 means. Okay, that's just how we have set it up. Okay, so when I write f of 25, I'm referring to the amount of money left to pay after 25 months. Can we come up with a formula for f of t? Sure, I think we can. So, after we just finished college, but before we've started paying our debt, we have $66,000 in our loan. Okay? So what that tells me is that, first of all, f of 0 is going to be equal to 66,000. right? And after each month, we are paying off some of our debt, which means that our debt is going to be decreasing, okay? So I think I want to have f of t, I want to have some expression that's a constant, and I think that's going to be 66,000. And then I want some expression which has something to do with t, right? And what makes sense here is that since I have f of 0 equals 66,000, that's how I decided what this constant here should be. Because when I plug in t equals 0, whatever I'm multiplying it by, we're just going to get 0 and the function is not going to change. So my question to you guys is, what should go in here? Should I have a plus or a minus? And then what should the number be that is associated with our t? Anybody want to try? Ashley, you already did one. Do you have one?
Yeah, it would be minus 1100 t.
Yes, it's going to be minus for sure because we're subtracting debt as we move along. And we want 1100. Perfect. Okay, so we came up with a formula for f of t. All right, using our formula for part C, find the intercepts and interpret them. Okay, well, we already found one intercept. F of 0 equals 66,000. Now, is that going to be a horizontal asymptote? Is that going to be a horizontal intercept or a vertical intercept? If we were to graph this, what goes on the left and right axis? Is it going to be t or d? It's going to be t. And then d is going to be on the vertical axis. So if I have 0, 66,000, yes, go ahead. It's going to be a vertical asymptote. It means we start at 66K. Let me do it in red. Okay, there we are at $66,000. Okay, so with that, how do we interpret that? We say at the start, we have 66K debt. Okay, now, how are we going to go about finding the horizontal intercept? Well, let's go back to our definition. What I said was that a x-intercept, a horizontal intercept, in this case it's a t-intercept, is going to be a point on the graph where the height of our function is equal to 0. Okay? Which means that what I want to solve here is my output should be 0. This is the part that I want to be 0, okay? So what I'm going to do is just write down an equation. I'm going to write down 0 equals 1,000 minus 1,100 t, and I'm going to solve this equation for t. Okay, so I'll just move the t over to the other side, so I get 1,100 t equals 66,000. And I will divide by 1,100 on both sides. That means that t is going to be equal to, what, 60? 60. Okay. So what does that mean? Well, I have d equal to 0 when t is equal to 60. That means that my debt is completely paid off after 60 months or 5 years. Okay? So, let's write, we're debt-free after 60 months. Okay. Kind of a lot of stuff in there. Yes?
Sorry, and that's the intercept, that's the y-intercept?
Yes, so let me write it explicitly in pink. Our horizontal intercept is going to be when our vertical value is equal to 0. Our vertical value we've described as d. So our horizontal intercept is going to be an ordered pair, the second number of which will be 0. The first number of which should be what? That's okay, don't panic. Sorry, I don't mean to like put people on the spot. So if my vertical is 0, that means that D is equal to 0, which means I have no more debt left. So the number that goes here should be the descriptor of how many months it takes for me to get debt-free. So it should be 60. And our vertical intercept should be an ordered pair where we have 0 for T, which means that we're at the start of our loan, which means I have all of it left to pay. So what goes here should be 66K. Good question. I want to remind you all that the horizontal intercept and the vertical intercept are points, right? They're an ordered pair, okay? So if I say, what is the vertical intercept, and you say 66,000, that's not exactly a complete answer, right? Because what I'm looking for is a coordinate in two-dimensional space where this thing is happening. So I'd like you to be able to describe that the t value should also be 0. Okay? So there's a little bit more information in an ordered pair than there is in just a number, and I'd like you to give it all. Okay. Any other questions about, excuse me, all of problem 8? Okay, we got about 9 minutes left, so let's do problem 9 and 10, and then we might be done after that. Okay, let 360 minus 20t equal h represent a hiker's height above a canyon floor in feet after t minutes. We want to find and interpret the intercepts. Okay, so same problem as D, what we just did. Okay, so first, let's first work on the vertical intercept. Okay, so let's draw our graph. And I'm just going to put in a dummy graph, but it'll probably look something like this. We'll start at a certain height, and then we're going down, 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 and then eventually we get to the canyon floor, and then we hang out there for a while, okay? This might be what our function looks like. So, our vertical intercept. First of all, let me ask the class, what should go on my vertical axis? The axis which goes up and down, what should go on that axis? Time or height? It should be height on this axis, and it should be time on this axis. We always put time on the horizontal axis so that we can just keep all of our graphs, which include time, of which there are many, consistent between them all. Okay, so time should go on the horizontal axis. And if I have a vertical intercept, don't know why I keep saying asymptote. If we have a vertical intercept, should my ordered pair have the horizontal value equal to 0 or the vertical value equal to 0? We should have our horizontal value equal to 0 because a vertical intercept means we're connecting here with the vertical axis. That happens when our t value is smack dab in the middle. Okay? So t is going to be 0. So if t is 0, looking at our equation here, 360 minus 20t equals h. If we plug in 0 for t, what are we going to get for h? 360. Okay, so let's interpret this. This says, at the start, hiker is 360 feet above the floor of the canyon. Okay. The way that we're going to solve for the horizontal intercept is going to be the same as what we did before. We know that for our horizontal intercept, we should have some number here, which is not 0, and then we should get 0 on this part, right? That's when we're going to have the horizontal intercept, is when our vertical height reaches 0, okay? So let's go ahead and solve that in terms of 360 minus 20t equals h. If we have 360 minus 20t equals to h, and our height is equal to 0, that means that 360 minus 20t is equal to 0, and that means if we move the 20t over to the other side, we get 20t equals 360. Divide by 20 on both sides, that means that t should be equal to 18. No. Yes, 18. Okay, yeah, t should be 18. Okay, so what does that say? That says that this ordered pair here is the ordered pair 18, comma 0. Okay, in terms of the problem, how can we interpret that? After 18 minutes, hiker reaches canyon floor. Okay. So another intercept finding problem. Any questions about problem 9? No? We good? All right. We'll do problem 10, and that'll be the last thing we do for today. So let's have group 4 on this side. You'll start with A. Group 3, you can do B. Group 2, you can do C. Group 1, please work on D. Yes. Yeah, sure. I can put it back on the screen really quick. Increasing and decreasing. If x2 is larger than x1, and when it's increasing, then f of x2 should be larger than f of x1. Okay. Okay, group 4. Have we had enough time? Need a little more time? We're okay? All right, what do we think? Should it be increasing or decreasing? Yes? Increasing. Okay, I'm glad we all came to a consensus. Okay, so the reason we can tell that this is increasing, right, is t goes up, and guess what? H also goes up. T goes up again. H increases to 8. T goes from 2 to 4. That's an increase. 8 goes from 8 to 64. That's an increase. This is an increasing function. All right, group 2 for B. Group 3 for B. What do we think? Increasing or decreasing? Yasmin? Decreasing function. All right, let's think about it. What's confusing about this one is they gave us t in the wrong order. They gave us 4, 3, 2, 1 for t. So really what we should do is start from here. Okay, if we start at 1 and we go to 2, we increased in t, but our r value decreased. We go from 2 to 3, t increased. Our r decreased. 3 to 4, t increased, but r decreased. So decreasing function. This one was increasing. Okay, we're out of time, so we won't do the last two. It looks like this one's going to be increasing, and this one down here should be, let's see, 72 to there. Yeah, this one should be decreasing as well. Okay, if you have questions, feel free to hang out after class for a second, or you can come to my office hour today at noon. I'll be sending you an email right after this class with the link for the YouTube and with the link for the exit slip and with the link for the blackboard and everything, okay? So,
Who's the SI? We got an SI in here.
oh yeah.
I'll hold my first session on Thursday.
Okay.
I posted a bunch of stuff on Blackboard,
Mhm.
sent out an email, but yeah. And then if my times don't work for you, we have a whole SI website. You can find an SI because all the classes do the same stuff, basically. So
So you said we don't need
But-
this, right?
We're,
Or do I need
yours is
it?
on Blackboard, right?
yeah, on Blackboard Collaborate, we're doing it all online.
Okay.
Okay, so can I ask how much you paid for this?
I'm not sure. My mom and dad bought it.
Okay. So you can use this, and this Wiley Plus code will work for you
Okay.
to get into the class. There's probably a cheaper option if you just go to the Wiley Plus page. You can
And
log
just, like,
in and
buy a
sign up on
subscription.
there, and it's like $69, and you can get like an electronic version of the textbook. So that's probably the cheaper thing to do, but that is perfectly fine if you want to have a hard
Okay.
copy.
But it probably makes more sense to just get the subscription or whatever.
That's what I would recommend.
Okay.
Yeah.
Alright, thanks.
Yes.
Hey, I don't know if you like take attendance from the like the seating chart or whatever, but I have the wrong last name on there.
Oh, okay. Yeah, no, I actually don't, but let me get your right last name on there. Where are you sitting?
Marshall is in the back, yeah.
And your last name's not Barron. What is it?
It's Bearing.
Oh, Bearing. Sorry.
Sounds kind of the same. B-I-E-R-I-N-G.
B-I?
E-R-I-N-G.
Bearing. Okay, got it. Sorry about that. Yeah, there's actually no attendance taken from this. The way that attendance is measured is just by
There's exit slip?
the exit slip.
Okay.
So you don't actually have to be here in the physical classroom if you don't want. You can watch the online lecture and then you can do the exit slip like that.
Alright, sounds good.
Yep.
Thank you.
Have a good one.
Thank you.
Derek, all right?
Yes.
Okay, question?
Do you post the class on Blackboard or just on YouTube?
I posted on YouTube, but I'll post the links on Blackboard.
Okay. You post it like right after or like later on?
It takes a little while for the video to process,